now we want to talk on addition and subtraction of matrices. Okay, now for matrix or matrices to be added or subtracted, the two must be of the same order. Okay, it is very important because the sum or difference is determined by adding and subtracting corresponding elements. Okay, so we cannot have a, let's say, 2 by 3 matrix, and for it to be added or subtracted from a 3 by 4 matrix. Okay, this is not possible. Okay, because let's take for instance the 2 by 2 3 the 2 by 3 matrix. Let's say we have it as written as A11. Okay, that means that's 2 rows and 3 columns, A12 and A13, and let's say A11, A21, A22 and A23, and we want to add these or subtract this from a 3 by 4 matrix, 3 rows and 4 columns. Let's call this B11, B12, B13, B14, and B21, B22, B23, and B24, B31, B32, B33, and B34. Now, the way addition and subtraction of matrices works is we pick individual components, okay, of let's say of every particular order of the elements. Okay, so A11 we added to B11, A12 we added to B12, or subtracted, as the case may be. Now when all these are now being done, okay, be A22 subtracted or added to B32. Now the question now lies that what happens to all these ones left behind. Okay, so it will be a big problem. So that is why for two matrices to be added or subtracted together, they must be of the same order. Very important, be of the same order. So with that, let's quickly take some examples. Okay, so let's say that we have 6 for, let's say, 4, 2, 3, okay, 5, 7, 6 being added to 1, 8, 9, 3, 5, 4. Now the first question we will ask is are they of the same order? Yes, we can say that this is these two matrices, okay, they are of 2 rows, okay, 2 rows and 3 columns, okay, 2 rows and 3 columns. So that's a 2 by 3 matrix. Okay, so the next thing we have to do is to pick individuals, okay, individuals at each point, so to perform the addition and also to perform the subtraction, as the case may be. But here we're considering addition. So first thing to do is to pick the elements bit by bit. So we have 4 plus 1, okay, and we have this, okay, 2 plus 8, and then we'll have the last one, 3 plus 9. Okay, then we continue on that way. 5 plus 3, this is centered at the bottom. 7 plus 5, and we have 6, and we have 4. 6 plus 4. Okay, so in that case we'll have 5, and we have 10, plus 2 plus 8 is 10. 3 plus 9 will give us 12. 5 plus 3 will give us 15. 7 plus 5 will give us 12. 6 plus 4 will give us 10. So our understanding of knowing, we were saying it the last time, but our understanding of knowing the previous the locations, okay, the locations of an element, okay, like we did here. Let's see in this video. Yes, that's what is the element of A24, what is the element of A42. Okay, so it's like to break it more further. Okay, so let's say we have two matrices. Let's say A, instead of 2 by 2 is A11, A12, and A21 and A22, and B is A, B11, B12, okay, and B21 and B22. Now we want to perform a matrix operation of A plus B, okay, and in that case, that means we are going to add the 1 variables, okay, the first column variables, we add them together. Now give us A11 plus B11, and then we take the first row second column variable, that will give us A12 plus B12, and we do the same thing for the individuals that are left. That's A21 plus B21, A22 plus B22. Okay, and if it is a subtraction, okay, we will have A11 minus B11, A21 minus B21, A12 minus B12, and A22 minus B22. Now, as the case may be, okay, now it is not limited. Okay, this whole process is definitely not limited to a 2 by 2 matrix. Okay, it can be applied to any order of matrix, provided that the matrix to be added, okay, or subtracted are of the same order. Now let's take, for instance, we are given that A is equals to let's say 2, 4, 5, 6, and B is equal to minus 1, 3, and 4, 0. Okay, I want to perform A plus B, and we also want to perform A minus B. Okay, now the first thing we ask is, are they of the same order? Or A is is an order of A of 2 by 2, and B is also an order of 2 by 2. Okay, then I will just ask, okay, yes, they are the same order. Okay, then how do I perform the operation? So my A plus B, okay, will all be 2. Okay, I'll take the 1 variables and add them together. That's 2 plus minus 1. Okay, I'll take the 1, 2 variables. Okay, the position, the elements in the first row and the second column. Okay, these are the 4 and 3. I'll take them also and add them together, and okay, that's 4 plus 3. I'll take the 2, 1 variables. Okay, that's the elements in the second row and the first column. That's 5 plus 4. Then finally the 2, 2 variables. Okay, that's 6 plus 0. Now 2 plus minus 1 will give me 2 minus 1, that's 1. 4 plus 3 will give me 7. 5 plus 4 will give me 9, and 6 plus 0 will give me 6. So with these, I have evaluated A plus B. Okay, now you notice that the resulting order of addition or subtraction, okay, are usually the order of the principal matrices that we are adding or subtracting. Okay, so let's perform A minus B. So we have 2 minus, we just change the positive to negative. Okay, minus 1, 4 minus 3, 5 minus 4, 6 minus 0. Now 2 minus 1 is 2 plus 1. That will give me 3. 4 minus 3 is 1. Yes, 5 minus 4 is 1. 6 minus 0 is 6. Okay, this is the most basic form of addition and subtraction. Now let's increase the format, okay, and go highly into from a 2 by 2 matrix, okay, like we did earlier. Okay, now we can now understand this, which I will repeat. So a 3 to a 2 by 3 matrix. Okay, so let's say we have 4, 2, 3, like we had earlier, and 5, 7, 6, and we want to add it to 1, 8, 9 to 3, 5, 4. Okay, or we want to subtract it, as the case may be. Okay, so now we'll see that of course they have the same order. There's 2 by 3 matrix. They have 2 rows and 3 columns. So we just take the individual row components, the individual rows and columns components, and then we do the necessary perform the necessary operations on each. Okay, so this is 4, this is 1. Okay, that is 4 plus 1 because of the addition sign. Okay, so we pick the first row, second column, first row, second column, add them together. The first row, third column, first row, third column. Okay, and this is the second row, first column, second row, first column, 5 plus 3, second row, second column, second row, second column, that's 7 plus 5. And the second row, third column, second row, third column. Okay, that will give me 6 plus 4. Yeah, so when the resulting of these will give me 5, 10, 12. Okay, and 15, 12, 10. Okay, now let's pick a final example of addition and subtraction of matrices. Let's say we have a 3 by 3 matrix that we want. Okay, we want to perform subtraction operation on. Let's say 8, 3, 6. Okay, 5, 2, 7, 1, 0, 4, and we want to subtract 1, 2, 3, 4. Okay, 4, 5, 6, and 7, 8, 9 from. Okay, now the first thing we will check also is that, oh, are they of the same order? Oh yes, I can see that the first matrix is 3 by 3, and then next thing is the second matrix 3 by 3. Oh yes, they are both 3 by 3, so I can go ahead and perform my operation on them. Okay, so that means the resulting, I will take the first row and the first column of both matrix, and that will be 8. I'm performing a subtraction operation. Okay, and then I'll take the first row, second column. Okay, first row, second column on the second. Okay, I'll give me 3 minus 2. I'll take the first row and the third column on both ends. That was 6 and 3. Subtract 3 from 6, and then if we repeat the same thing for everything, we will end up having 7 or this following. Okay, we just take the corresponding row number and the column number, row column number, okay, according to the double suffix notation, and then we perform our subtraction from operation on it. So this will give us 8 minus 1 is 7, 3 minus 2 is 1, 6 minus 3 is 3, 5 minus 4, that's 1, 2 minus 4, 5 minus 3, and then we go on and on like that. Okay, so essentially this is how addition and subtraction of matrices work. Now we want to go over quickly into multiplication of matrices. Okay, now there are 2 forms of multiplications. Okay, we have the scalar multiplication, and we have the vector multiplications. Okay, so the scalar multiplication is like a matrix multiplied by matrix multiplied by a single number. Okay, a single number by a number. Okay, and this a vector matrix is a matrix actually multiplied by another matrix. Okay, and most of the time students find vector matrices, vector multiplication of matrix very quite confusing, and at times it becomes irritating because the principles are not taken into consideration. So we will look at both vector matrix, and also we'll look at scalar matrix. Okay, and we will see how best, okay, all the opinions, so we will split them down to know how far. So let's start with scalar matrix, scalar multiplication. Okay, for scalar multiplication, It's quite simple. Okay, the matrix is multiplied by a single number, that is like a scalar number. So let's take, for instance, I have AB and I have CD. You notice that the matrix is a 2 by 2 matrix. Okay, now I want to multiply it by a variable. Let me call that number, okay, k. Okay, the k is scalar. Okay, and our matrix is ABCD. Now in this case, all I just have to do is to multiply each element. I will multiply each element of my matrix by k. So this will give me KA, KB, KC, and KD. Okay, so once I have multiplied each element by k, then it is also sorted out. So now let's take for instance, I have 2 multiplied by 1, 2, 3, 4. Okay, this is a scalar multiplication. So we might be given a matrix of 1, 2, of row 1, 2, and another row 3, 4. And we want to perform a scalar multiplication by a scalar quantity of 2. So in essence, I am saying that we'll multiply 2 by all the components or elements of the matrix. Okay, so we will have 2 into 1, or 2 multiplied by 1. Okay, then 2 multiplied by 2, change this, and then we'll have 2 multiplied by 3, 2 multiplied by 4. Okay, and this will give me 2, 4, 6, 8. Okay, so scalar multiplication and the scalar quantities can also be negatives. Okay, the scalar quantities can also be negatives. Okay, so let's say instead of multiplying by 2, I was asked to multiply it by let's say minus 3. Okay, so I can now have that this will be minus 3 times 1, minus 3 times 2, minus 3 times 3, minus 3 times 4. Okay, this will give me minus 3, minus 6, minus 9, and minus 12. Okay, so scalar multiplication can come in any format. So now we can involve scalar multiplication and incorporate it into addition and subtraction of matrices. Okay, which will quite make it more fun. Okay, so if we have two matrices, or let's say matrix A is given as let's say 1, 2. Okay, 1, 2, 3, 4, 5, 6, and now matrix B is given as 4, 3, 4, 2, 3. Let's move this a little bit, and 5, 7, 6. Okay, and we are asked to evaluate 3A plus B. Okay, so in 3A plus B, all we just have to do is substitute. So if we move this center, okay, now the mathematics is very simple. It's just the operation of addition, subtraction, multiplication, and division. Okay, so let's substitute each and every one of these components. So let's put in A as a matrix 1, 2, 3, okay, 4, 5, 6, okay, and B to be matrix 4, 2, 3, 5, 7, 6. Okay, we have our addition sign here, and then we realize that that 3 there, okay, will be like a scalar multiplication. Okay, so now we perform this scalar multiplication first. We have it to be 3 times 1, okay, and by 3 times 2, and 3 times 3, 3 times 4, 3 times 5, and 3 times 6. Now with this done, we can now perform let's multiply out, and we have our answer. So we have 3, 6, 9, 12, 15, and 18. And then we can now add them to 4, 2, 3, 5, 7, 6. Very good. So now we can easily perform our addition equation operation. So we have 3 plus 4, okay, we have it to be 12. 6 plus 2, we have it to be 8. 9 plus 3, we have it to be 12. 12 plus 5, okay, 12 plus 5, we have to be 17. 15 plus 7. Okay, we have it to be 22, and 18 plus 6, we have it to be 24. Okay, so it can also be division, so it can also be subtraction. Okay, so let's say 3a minus b can also be done. Okay, it can be 2a minus 3b, and the questions can come in any format. Okay, so far we understand the principle of addition and subtraction must be done like the operations must be performed in such a way that two matrices must be of the same order. Now moving on, we want to talk on vector multiplication. Now we know that vector multiplication is done between two matrices. Okay, now we have matrix multiplied by another matrix. Now the principle is quite unique, in the sense that two matrices can be multiplied together only when the number of columns in the first is equal to the number of rows in the second. Okay, so let's say my matrix here is of L by M, and my matrix here is of M by N. Okay, now we realize that this number, okay, we'll notice that the number of rows in the first, okay, let's call this M, and it's also M. Okay, we'll realize that the number of columns in the first matrix is the same as the number of rows in the second matrix. Okay, so the resulting matrix will be L. Okay, the order of the resulting matrix will be M L by N. Okay, will be L by N. So so understand this better, let's have two matrices. Okay, let's have a table. Let's call this matrix A, matrix B of order. Okay, and is it possible? And then at the end we will now have that what is the result? Okay, so now let's have a matrix of 2 by 2 multiplying another matrix of order 2 by 2 matrix. Now we will see that the number of columns in the first matrix is the same as the number of rows in the second matrix. Okay, so yes, it is possible. Okay, and if it is possible, then we will have what? The result will be 2, okay, by 2 order. Okay, now let's take another 3 by 2. Okay, is now, let's say it is multiplied by a matrix of order 2 by 4. Now we can say that the number of columns in the first matrix, that matrix A, is the same as the number of rows in the second matrix. So yes, it is possible. And if it is possible, the result of the matrix, okay, of the multiplication process will be 3 by 4. Okay, now let's take another one. Let's say I have a 3 by 5 matrix, and I want to multiply by a 3 by 3 matrix. Okay, is it possible? Because the number of rows, the number of columns in my first matrix is 5, and the number of rows in my second matrix is 3. Now we can see that 5 and 3 are different, so it is not possible. No. Okay, simply no. Okay, so we won't have a result. Okay, so finally, so let's say we have another of 2 by 3 matrix, and this is multiplied by 3 by 1 matrix. Okay, so we have that this number of rows here, or number of columns rather, this is the number of columns of the first matrix, and this is the number of rows of the second matrix. So are they equal? Yes, if they are equal, then the result will be okay. So it's possible, because the number of columns in the first matrix is equal to the number of rows in the second matrix. So yes, it's possible. Then the result of the matrix will be 2 by 1. Okay, now how then do we now multiply matrix? Okay, now let's take for instance we have a 2 by 2 a 2 by 3 matrix multiplying a 3 by 1 matrix. Okay, so 2 by 3 matrix multiplied by a 3 by 1 matrix. Okay, so let's say that 2 rows, okay, and 3 columns, a12, a13, a21, a22, a23, and it is now multiplied by a 3 by 1 matrix. So let's call this b11, b12, b122, and 23, or let's simply call it, let's assume it is a 3 by 2 matrix. Okay, b12, b122, and b23. And the first thing we'll ask is the number of columns in the first matrix is 3 and the number of rows in the second matrix is 3. So are they possible? Yes, it's possible. The result of the matrix will then be what? 2 by 2 matrix. Okay, so then how then do we now perform this? Okay, and this is where we will try our best not to get ourselves lost. Okay, this is very, very important. So the order of multiplication of matrix is that the elements of a row column of the row in matrix A is multiplied by the corresponding elements in the column of matrix B. So that means we are taking the row, okay, and we are multiplying it by the column. Okay, we are taking the row and then we are multiplying it by the column. Okay, so now to get the first row, that means I'm saying that this, okay, is multiplying this, and this is multiplying, there is another ink, is multiplying this, and this is multiplying this. Okay, now the row column, the row element is multiplied by the column element. So in essence, we are saying that a11, b11, okay, we are adding it to a12, b22 plus a13, b23. Okay, now after that is done, we have already gotten the first element. Remember, the result is a 2 by 2 matrix. Okay, so if the result is a 2 by 2 matrix, then we have already gotten the first element of the 2 by 2 matrix. Now to get the second element, okay, to get the element here, okay, we have to use the first row. Okay, this element here is the first row, okay, and the second column. So we multiply the first row of matrix A, okay, so we multiply the first row of A, okay, and then we multiply it by the second column of B. Okay, now we realize that this, what we have here, okay, let's even try and do this. Let's reduce and understand what we have here. Now to get the first element here, we are going to use first row of A, okay, multiplied by the first column of B, and this element here will be the first row, okay, of A multiplied by the second column of B. Now this one we are now in the second row, okay, of A, and we are now multiplying by the first column again. We are still on the first column of B. Now this is the second row of A multiplied by the second column of B. Now with this done, now we can now henceforth now have the elements written in this format. Okay, but I think we might have to rewrite this format out, the questions out, so that we will have a better view of what we are doing. So we are having A11, A12, and A13 multiplied by A21, A22, A23, and then we have B11, B212, okay, and then B21, and then B32. Okay, now since we are dealing with the first row of A, okay, we are doing the first row of A and the first column of B. So our first column will be dealing with this and with this. Okay, so we will multiply each individual one to get we have A11, B11 plus A12, B21 plus A13, B31. Now after that is done, to get this one, okay, we will have the first row multiplied, okay, we have the first row multiplied by the second column. Okay, so we'll have A11, B12 plus A12, B23 plus A13, B32. Now to get for this element here, okay, we will have the second row multiplied by the first column. Now with that we'll have A21 multiplied by B11 plus A22 multiplied by B21 and A23 multiplied by B31. And to have the last one here, you are still on the second row, but now on the second column. Okay, now we'll have A21 multiplied by B12 plus A22 multiplied by B23 plus A23 multiplied by B32. Now if we understand this simple multiplication, okay, of the first row of A multiplied by the first column of B, okay, and then we are not limited by this, okay, so that this analogy we used was a 2 by 3 matrix multiplied by a 3 by 2 matrix, okay, and we can see that the result is 2 by 2, okay, as we have seen here. Okay, so with that done, now next video we'll be looking at examples of multiplication and division. Examples of vector multiplication, or of matrix multiplication. So we take various examples on it, and with that we'll be able to come to an end of the next video.